Good morning, everybody. I want to review with you just a few points from what you read, heard, and what we talked about yesterday. Very briefly, I want to talk to you about stellar magnitudes. Now, here's a key point. Whenever you see the word stellar, just think of star. So if I say stellar evolution, I'm just talking about the process of how a star undergoes changes throughout its lifetime. When I say stellar magnitude, I'm just talking about the brightness of a star. So, stellar magnitudes, all that means is how bright stars are. We've all looked up at the night sky, you've all looked at stars, and you know that some of them appear brighter than others. Well, why is that? A couple reasons, which we'll talk about in just a second. But from yesterday, when you did your questions and you looked at these notes, I just want to go back and make sure everybody's okay with what we talked about. When you look up from the Earth, there's only about 6,000 or so stars that you can actually see with the unaided eye. Now, you can see about 3 billion or so with telescopes from the ground. But when you get above the Earth's atmosphere, that's when you can really look deep into space, and over 1 trillion stars can be observed. Now, the reason is obviously once you get above the Earth's atmosphere, it's a lot clearer. There's nothing in the way. There's no weather. There's no clouds. There's no any kind of small debris, dust particles in the atmosphere. All that blocks light, and it also refracts and bends the light and gives you a false sense of reality. So once we get above the Earth's atmosphere, really gets a much clearer picture of the stars. This is the very famous Hubble Deep Field image. And one of the things we talked about earlier on when we looked at this is everything that's in there, there's a lot of differences, but one of the differences is brightness or magnitude. Luminosity is another word. So when you look at this picture, you realize some of these are a lot brighter than others. Well, why is that? Well, there's two reasons really. One, they're a lot closer, or two, they're a lot bigger. And so there's a lot more energy being given off. So it sort of depends on each situation. And remember, a lot of these in the Hubble Deep Field, a lot of these we're looking at here are galaxies, which are just massive amounts of stars in a collection. But when you look up at the night sky, and for example, if we look at Orion over here, we can see that some of the stars in Orion are a bit brighter than others in the constellation, and indeed others around them. Over here we have a cluster of stars right here, and you can see that some are much brighter than others. We talk about apparent magnitude. Apparent magnitude is how bright is a star as it appears from Earth. Now, interesting how they do this in astronomy, but the lower the number, the brighter the stars. If you're a baseball player, the lower your ERA, the better pitcher you probably are, or the better defense you've got behind you. But apparent magnitude is just that. How bright is a star when you look at it from Earth? So, for example, the sun has an apparent magnitude of about a minus 27 or so. That's very bright. Over here, a magnitude of positive 6, that's about the brightest star we can see with the unaided eye, with the naked eye. Some stars like Vega and Sirius, they are relatively bright. We know how bright Venus is in the morning. It's about a magnitude minus 5. So that's apparent magnitude. Now, the true brightness of a star, or how it would appear if you looked at it from a distance of 32.6 light years from the Earth, that is called absolute magnitude. And if you remember, 32.6 light years is 10 parsecs. So in other words, if we took all the stars and lined them up, theoretically lined them up at the same distance away, that would give us an absolute magnitude. We could really see which one is brighter. if they're all lined up together.